This conference will now be recorded.
Yeah, hello students, good evening. I'm going to discuss today the concept of transaction management. Okay, here we will understand what is mean by transaction. Okay, what is mean by transaction we'll discuss. So far we have discussed various queries. Right, query for updating salary, query for doing that one, this one, so many we have discussed. Now, what is a query? Query is nothing but a request to the database system. Query is nothing but a request to the database system. Suppose there is a query that is transferring balance from account A to account B. Let us say 100 it is transferring from account A to account B. Okay. How this transfer is going to take place? This transfer is going to take place. How? First, it should read the current balance of account A. So how transfer is to done? Debit from account A, credit into account B. First, read the current balance of account A. Then account A equal to account A minus 100. Then perform write on A, update it. So means first read the current balance and first debit that 100 from A and updated balance right back to the disk. Once amount is debited, it requires to credit into account B, read B. Then it requires to perform adding 50 to B. And then we have write B, update B. Then you perform a commit operation. Then we perform a commit operation. Okay, then we perform a commit operation. Now, what is here? What is this transaction T that is transferring some 100 rupees from account A to account B? So whenever you are transferring some balance from account A to account B, it requires to debit that 100 from account A, then credit that 100. Okay, here, sorry, not 50, 100 to account B. Now, see, this is a collection of operations. These are called the collection of operations. That all these operations are executed together. It is performing one particular task. The task of transferring 100 from account A to account B. This process, the transferring 100 from account A to account B, this process, entire process, which is a collection of operations, is called one transaction. Here we can say transaction, it is a collection of operations. It is a collection of operations that performs a logical unit of work. That performs a logical unit of work. You are executing some queries on a database system. It is meaning that you are performing a sequence of operations, a collection of operations you are executing. If you are executing that collections of operations, which is performing a logical unit of work, is called one transaction. Right. Now, here, this I can call transferring balance from account A to B is one transaction, which is transferring from balance from account A to account B. So which requires to debit from account A, credit into account B, then update should become permanent. We have to use a commit operation, right? If you see any transaction which is not just one operation, which is a collection of many operations, because it is a collection of many operations, we can call it as one transaction. Fine. Now we understood what is mean by transaction. Every transaction that when executed requires to satisfy certain properties. Here we call transaction properties. Any transaction that when executed requires to perform certain operations is called property of a transactions. Now, what are the properties of a transaction? Every transaction requires to satisfy 4 properties. The first property is called atomicity property. What is atomicity property? Atomicity property says if any transaction that need to be executed, it requires to execute either all operations of a transaction or none of the operations of a transaction. Either perform all operations or none of the operations. If it performs either all or none of the operations, then the system should be in a correct state. Otherwise, system may be incorrect state. Let me explain why inconsistent, why incorrect, why correct state. Suppose the balance of account A is 1000. The balance of account B is 500. Assume a case. When this transaction need to be executed, first it will read the balance of A, that is 1000 minus 100, 900, write to the disk 900. Okay, it is updated to the disk, the value 900. Then read B 500 plus 100, 600, write B 600. Now this is changes to 600. Then commit makes these two updates become permanent. Now it is very clear that amount is debited from account A, credited into account B, and transaction is success, state of the system is correct. Suppose if no operation is executed, we can call transaction is failed. We can say transaction is failed. If no operation is executed, we can say transaction is failed. But you see, if no debit, no credit, transaction is failed, but amount is not debited from account A, not credited into account B. So means no loss, nothing. You can re-execute the transaction. Suppose if there is a failure occurs while execution of this transaction, if there is a failure at this point, if a transaction failed, maybe different reasons are there. Maybe user who is executing the transaction intentionally made the transaction to become fail, or else there may be different possibilities like a disk crash occurs, head crash occurs. There may be many reasons for the failure of a transaction. Means while this transaction is executing, this transaction is failed at this point. At this point means after debiting from account A before crediting to account B. After debiting from account A means account A is going to become 900. After account A become 900, if a failure occurs, now it causes a loss because 1000 is already overwritten with 900 right now. Because 1000 is already overwritten with 900 means what is the values there on the disk? 900. Because a failure occurs, amount is debited from account A but not credited into account B, causing a loss. Now, when there is no loss, if transaction executed all the operations, means debit credit is done, then we can call system is the correct state. No debit, no credit also we can say system is correct but transaction is failed. But if executed some of the operations, here if it is executed up to this only and causes a failure, if it executes up to this and causes a failure, then it results an incorrect state. Is it the correct state? 900. Account A is 900, account B is 500. When transfer is takes place, no, incorrect. So it means it. That means if any database system state to be correct state, that is possible if all the operations of a transactions are executed or no operations of a transactions are executed, then it is a correct. If neither all nor none means if it is only some of the operations, then the system may go into incorrect state. The system may go into incorrect state. We also called inconsistent state. So to ensure correctness of the database system, it requires to satisfy atomicity property. Then in a database system, you may ask me a question, who is responsible for ensuring this atomicity property? So there is no person is going to be involved. System should take care, and to ensure correctness, the transaction has to complete all the operations or no operations. This property is to be verified by the database system component called transaction manager. Transaction manager, which is responsible for verifying all the operations or no operations of a transactions are executed. If all are executed, if none of them are executed, then transaction manager will not do anything. If neither all nor none, if only some operations are executed, like this, after executing some operation, a failure occurs. Then after some operations, a failure occurs. Then what will happen? Then transaction manager identifies that the system is in the incorrect state. If the system is in the incorrect state, it requires to report to the recovery management component. So that recovery management component is going to recover from the failure. How? Simple recovery approach is called rollback. Rollback in the sense, just undo this. Undo this means A is updated to 900, reverse it, that A is changes to 1000. So making this A to 1000. Now it is correct. So what is happening if any failure occurs? That is to be recognized by whom? Transaction manager. After transaction manager recognizes, now transaction manager should report to the recovery manager. Means it is a recovery system. What recovery system will do? Will perform a rollback action so that the database system should go into the previous correct state. Now, if you re-execute the transaction or do not re-execute the transaction, it is not causing any problem. Now the transaction can re-execute to ensure correct state of the system, right? Okay, this is atomicity. And the second property is called consistency. Consistency means it is a correct state of the system. Consistency says correct. So before a transaction starts, the state of the system should be correct. And after the transaction completes, then also state of the system should be correct. So means state of the system should be correct before and after the transaction. Okay, that is what we call correctness. Consistency means correctness. Who will verify the consistency of a database system? Consistency is going to be verified by the programmer who writes program over the database system, called application programmer. Right? So here, what is mean by application programmer? Database is the backend, and front end you can see some application program. Okay, you can see some application program as a front end, where you can see some screen. Like this application program can be written using some front end programming languages like Java or Python or any other things. Suppose here we have to enter account A details, account A number, account B number, and the amount to transfer, a text box, and there is one button called submit. Now whenever you click on this submit, button, it should read the account balance A. Sorry, it reads the account number A and account number B, and perform the required amount. Let us say 100 is to be debited from account A and credited into account B. This screenshot means this screen user interface has to be prepared by whom? Programmer. Now programmer should write the programs in a proper way so that whenever the program get executed, the state of the system should be correct. It means whoever the programmer coding this program should code the transactions properly. Otherwise, it may lead to incorrect state. Let me give a simple example. So here, transferring from account A to B requires minus from account A, debit from account A, and then credit into account B. Debit from account A, credit into account B. Debit and credit. Okay, debit and credit. Debit from account A, credit into account B. Okay. Now, what this debit and credit requires, so means the programmer who codes this program should code it properly. First debit from account A, then credit into account B. But the programmer who writes this application program front end has coded this transaction in this way. Means first credit, add it, and then debit it. Now here is the system knows that first it has to perform debit then credit or credit then debit? No. Whatever the transaction is coded by the programmer, the transaction is going to be executed. Suppose if the programmer who codes this transaction as addition then subtraction, then what is going to happen when you are trying to transfer some amount from your account to your friend's account? What is going to happen? It is reversely debiting from your friend's account, credit into your account. So means when you are transferring some money from your account to your friend's account, because the programmer who coded wrongly, because of program that coded wrongly, it is reversely coming from your friend's account to your account. Correct? Your friend's account to your account. System cannot identify. That's why such kind of errors to be identified by whom? Application programmer. Means consistency is to be verified by the application programmer. Third one. So means whenever programmer writes this kind of programs, programmer should verify in all cases, is the program working correctly or not, has to be verified. If not working correctly, then he has to make some corrections to the program. The third property is called isolation property. The isolation property says that all the transactions that are executing, each transaction that when executed, each transaction that when executed do not know what is happening, do not know what is happening in other transactions. So means each transaction do not know what is happening with other transactions. So means each transaction executes isolatedly, independently, without knowing what is happening with other transactions. Then if each transaction executes isolatedly without knowing what is happening with other transaction, that may causes some problems. Let me give a small example. Listen to me carefully. Are you listening? I think it is a bit dry, but interesting. Listen to me. Okay. Some small example to verify isolation property. Say, let us say an example. This is my account. My account is having 1,000 rupees. Okay. I requested my father to deposit 1,000 rupees into my account. So what he will do? Suppose he went to one of the bank branches and gave that 1,000 rupees and my account number to the accountant and asked the accountant to credit into my account. So what accountant will do? Accountant will execute one update action on my database. That is, my database is going to be added with 1,000 rupees. That update query requires to read the current balance. Then current balance is to be added with 1,000 rupees. Then update that updated balance to the account A. Similarly, suppose if I request my brother also to deposit 1,000 rupees, and even my brother did the same thing, so that it reads current balance of account A, then add that account A with 1,000 rupees, then perform a write on A, so that updated balance, so that the updated balance updated to that disk. Okay, this is done by my father and my brother, assuming these are the two independent transactions. Now I can call this is F transaction and another one is a B transactions. If F and B are independent transactions and executing simultaneously, because F don't know what is happening with B, B don't know what is happening with F, it means both F and B are executing simultaneously. Now, suppose F executed this operation, second B executed this operation, next F executed, next B executed, next F executed, next B executed, and so on. F and B are executing simultaneously. If both F and B are executing simultaneously, then what is going to happen? Look at read current balance A, 1000. Next operation is second operation, read current balance of A by B transaction, 1000. Next third operation, A equal to A plus 1000, that is 2000. And do remember, this is a CPU operation, and CPU operation not going to affect to the disk. It is not affecting the disk. Then write A. Sorry, next fourth operation, A equal to A plus 1000. Now what is the value of A? 1000 plus 1000, 2000. Do remember, the value of A at this fourth step for transaction B, the value of A is only 1000, not 2000. Why? Because B do not know what is happened with F. That is what we call isolation. B don't know what is happening with F. F don't know what is happening with B. Next, write A. Write A is 2000. So it is write A. Do remember, write A writes to the disk value 2000. And here, this whenever F is executing write A, it don't know what is happening with B transaction. Means F don't know what is happening with B transaction. B don't know what is happening with F transaction. Now after this is executing write A, sixth operation. What is the A for B transaction? 2000. Not okay, it is 2000. And moreover, B does not know what happened with F transaction, so that it is going to write the value 2000 written to the disk. So means 2000 is overwritten by 2000 by the B transaction. Now look at any loss occurred. Look at any loss occurred. Yes, here loss cost. What is the loss? Because my account is already 1000. When my father and brother both gives 1000 each, my account should become 3000. But here it became 2000. Means it causes a loss of 1000 rupees. Right now, why this loss occurred? Because of isolation property. Because of isolation property, this loss occurred. Now in a database system, there should be someone to take care of this isolation property. In a database system, we have a component called Concurrency Control Manager. Concurrency Control Manager means manager is nothing but not a person, it is a program. Okay, Concurrency Control Manager, which is responsible for concurrent execution of the transactions, so that whenever the transactions execute simultaneously, it may lead to problems. Just now I shown. But what Concurrency Control Manager should do? It should execute in a way, it should control that execution, so that execution always leads to correct state. Okay, it should never be incorrect state. Let me give a small example. Say account A is having 1000 rupees. Okay, account A is having 1000 rupees. Now what Concurrency Control Manager do is it should control that execution. So most of the Concurrency Control Managers uses locking protocols for the concurrency control. Suppose F started first. What Concurrency Control Manager do is it is going to give lock to F. So means F is going to lock that A transaction, A data item. And do remember, when one transaction locks a data item, any other transaction like B wanted to access A is going to wait. So means after F got a lock on A, B transaction has to wait for the F lock to be released. Look at what is going to happen now. Read A, it is going to read 1000. Next second operation is this one. Read A means before performing read A, B transaction should get a lock on A, because lock on A is already taken by F. So what B transaction should do? It is going to wait. Because it is going to wait, F is active now, so F is going to continue its execution. So means here it is only stopped. Before it performs a read only, it is stopped. Wait. Now plus 1000, 2000s, write to the disk 2000s. Write to the disk 2000s. Done. After it writes 2000s, after it writes, okay, let me show. After this 1000 changes to 2000s, operation of F is completed now, because once operation of F is completed, now what it should do, F is going to release the lock. After F releases the lock, then B should get a lock on A. B should get a lock on A. Now after B acquires lock on A, now what B should do, read the account balance A. Now, sorry, 1 minute. Look at 1 minute. First F got a lock, read 1000 and plus 1000, 2000, write to the disk 2000s. Right after F completed, lock on F is going to be released. Then B gets a lock, B takes a lock on A. Now, because no more waiting, because B taken a lock on A, no more waiting. Now what B should read? B should read the value 2000 from the disk. It is 2000s. Plus 1000, it is going to become 3000s. Write to the disk how much value? 3000s. Done. Any problem occurs? Any problem occurs? No. Why? Because the execution of F and B transactions on a database A, the concurrency control manager controlled that execution, so that previously we got an inconsistent state. Now we don't have any inconsistent state, right? Now we don't have any inconsistent state, right? That is the responsibility of a concurrency control manager. And finally, one more property, that is durability property. And these properties are important for the interview point of it. That's why I will be taking this much time. Durability property. What durability property says is, all updations done by a transaction should become permanent, update. So means here, whenever a transaction performs a write operation, that write operation on the disk will be considered as a temporary updates, but not a permanent update. Why? Because if it is temporary, at any point of time you can undo the operations, means you can reverse it so that it can retain the old values. But if it is retaining the old values, means we cannot say the transaction is completed. We can say transaction is completed only after it executes the commit operation. Once transaction is committed, the updates done by the transaction should never be undone. So means we can call transaction is success. So durability property requires to have the same thing. Means all updates done by a transaction should become permanent. Otherwise, we can call a problem may be occurred. Means, let us an example. If debited from account A, credited to account B, done. But before commit, if a failure occurs, it is possible to roll back both debiting from A and crediting into B. Both you can roll back. But once it is committed, now it cannot be changed to its old value. That's why we can say making the updates to become permanent. If the updates are not become permanent, if a failure occurs before commit, means it is incorrect state. So if it is incorrect state, in a database system, we have a component called recovery manager, which is responsible for recovering the data that is there before the failure of a transaction. So that durability property is going to recover the data from the database system, right? So means here I told you what is atomicity property. Execute all the operations or none of the operations. Responsibility is a transaction manager. If a transaction manager identifies neither all operations nor none of the operations are executed, it means that state is incorrect. We call inconsistency. That inconsistency may cause due to isolation property. If inconsistency occurs, updates are not become permanent. If updates are not become permanent, we require to take the help of recovery manager so that it will recover from the database state that is existed before the failure occurs. These are the 4 properties of any transaction, and these 4 properties: atomicity, consistency, isolation, and durability. From the first letter of each properties, these properties are called acid properties. These properties are called acid properties. What is acid? A for atomicity, C for consistency, I for isolation, D for durability. Here it is very important for you for the placements. Means you may not expect any objective questions on transaction management, like what is acid properties and all. But definitely, if you have a knowledge on databases, they definitely will ask you a question on what is transaction. This is one of the important question. They may ask you what is transaction and what are the properties of a transaction, and they may ask you explain each of the property. Like atomicity says execute all the operations of a transactions or none of them. Consistency says database system is correct before and after the transaction. Isolation says each transaction is independent of other transaction, means each transaction don't know what is happening with other transactions. Durability says all updates done by a transaction become permanent updates. And who is responsible for each property is also important. Atomicity is responsibility of transaction manager. Consistency is the responsibility of application programmer. And isolation is the responsibility of concurrency control manager. Durability is the responsibility of recovery manager. These points, 90% possibility is there. They may ask you what is acid properties, what are the acid properties, who is responsible, explain what is atomicity, explain what is consistency, isolation, durability. They may ask you. Okay, these are called acid properties. Fine. Is it clear? Any doubt? So if you have any doubt, you can ask me before I go to the next topic. Okay, I made you very much clear what is transaction properties called acid properties. If you have any doubt, before I switch to next topic, please ask me. I'm waiting. Any doubts? No? Okay. If nobody, because nobody is asking, I can assume that no doubts for you. Can I assume? Okay, clear, Vamshi. Nice. Chalo. Next, I will show you how transactions are executing. What is the states of a transaction? Look at. If a transaction is executing, when transaction is executing, we can call active state. Active means transaction is executing. Active means transaction executing. Okay, do remember transaction executing. Once transaction completed all the operations, here you look at. Once transaction completed every operation except commit. If a transaction executed all the operations except commit, we can call it is partially committed. We will call partially committed. Once these updates become permanent, then it is called committed state. Then it is called committed state. And do remember, failure may be possible. Failure may be possible before a transaction committed. Means while executing the transaction, failure may be possible. Or even after partially committed, means all the operations of a transactions are executed, failure may be possible. Means if a failure occurs, transaction has to recover from the failure. Once transaction is recovered from the failure, that state is called aborted state. That state is called aborted state. Means transaction caused any failure and system got recovered from the failure, we call aborted state. And do remember, transaction is possible to become a failed before it is committed. Once transaction is committed, it is not coming into the failure state. Failed state, it is not coming. Once a transaction is failed, it is to be recovered from the failure. The state after recovering from the failure is called aborted state. Okay, it is called aborted state. Fine. These are the 5 states of a transaction. These are called states of a transaction. These are the 5 states of a transaction. These are the 5 states of a transaction, right? So means if you see any transaction, the transaction will be in one of these 5 states. Maybe executing, or maybe executed all the operations of a transaction, we call partially committed. Once it is completing all the operations, we call it as committed state. And failure is possible before it enter into the committed state, then it moves to the aborted state. Okay, fine. Next. Is it clear? Done. Now here we understood what is a transaction. What is a transaction? It is a collection of operations that performs a logical unit of work. What are the properties? Atomicity, consistency, isolation, durability, acid properties. The transaction should be in one of these 5 states: active, partially committed, failed, committed, aborted. When we call transaction is active, if transaction is executing, we call it is active state. If executed all the operations except commit operation, we call partially committed. Even commit is also executed, we can call committed state. Do remember, once transaction is committed, it cannot be undone. Okay. And failure is possible. A transaction, if it is active or partially committed, it may go into the failure state. Once a transaction is failed, it has to be recovered from the failure. The state after recovering from the failure, if it is recovered from the failure, we call the transaction is aborted. Okay, these are the 5 states. Now we will understand how transactions are going to be executed. The way the operations of a transactions are executing, previously I have shown you. This is F transaction, this is B transaction, and F and B are executing in this way, right? First F operation is executed, then B operation, again F, again B, again F, again B, right? This is continued. Now the way of executing the operations of a transaction is called schedule. It is called the way it is executing the operations of a transaction is called schedule. Now what is a schedule? What is a schedule? Now schedule is representing the order in which operations are executing. Here you look. First F operation is executed, then B operation, again F, then B, again F, B. That kind of execution is called schedule. Means schedule represents the order in which operations of a transaction are executing. Schedule represents the order in which operations of a transactions are executing. Means in what order the operations of a transaction are executing, that order is called schedule. That schedule is representing the order. Okay. And here we do have 2 types of schedules. Generally the schedules are classified into 2 types. We called concurrent schedules and one is called serial schedules. The serial schedule is nothing but the transactions are going to be executed serially, one by one. So means first transaction 1 executed. During the time transaction 1 is executing, no other transaction is active. Then transaction 2 is executed. Means execution is serially. T1, then T2. Or else first T2 executed. During the time T2 executed, no other transaction is alive, and then T1 executed. then we can call it as a serial schedule T2 to T1, that execution. So here we do have it two transactions. If two transactions, how many serial schedules are possible? Two serial schedules are possible. One is first T1 then T2, second is first T2 then T1. And if three transactions are there, how many serial schedules are possible? Six possibilities. What are the six possibilities? 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. Totally, how many possibilities? Six possibilities. If three transactions are there, six possibilities. Now, it means if two transactions are there, 2 factorial possible serial schedules. If three transactions are there, we have a 3 factorial serial schedules. If n transactions are there, then how many serial schedules possible? N factorial serial schedules. Just we discussed some example of concurrent execution where my account A is going to be credited by my father and my brother with 1,000 rupees each. Suppose if these two transactions T1 and T2 means that F and B transactions execute serially one by one. If one by one if executes, now first F transaction gets executed. Let us say read A 1,000 plus 1,000, 2,000, write to the disk 2,000s. Once F is completed, if B started, means first T1 then T2, assuming this is F transaction, this is B, or else this is B transaction, this is F, whatever it may be, executing serially. Then next B transaction executed, it is going to read 2,000 plus 1,000, 3,000, so write to the disk 3,000s. Any loss occurred? No. So what does it mean is, if transactions execute serially, if transactions executes serially, if transactions executes serially, if transactions are going to execute serially, the database system always in a consistent state. The database system always in a consistent state. This is a note point. It means a serial execution always leads to correct state of the system. It should never be incorrect state. And if transactions are executing concurrently, may leads to incorrect state. Second one. So one type of schedule is called serial schedule. Second type of schedule is called concurrent schedule. Simultaneous execution is called concurrent schedule. What is mean by concurrent schedule? Concurrent schedule mean that transactions are going to execute simultaneously. Suppose two transactions are executing, T1, T2. First, T1 executed 2 operations. During the time T2 is idle. Next, T2 executed 3 operations. During the time T1 idle. Next, T1 executed 3 operations. During the time T2 idle. Next, T2 has started execution, executed 2 operations, and so on. This kind of execution means sometimes T1, sometimes T2, sometimes T1, sometimes T2, and so on, is called concurrent execution. Means it is simultaneous execution of the transactions. Simultaneous execution of the transactions. That simultaneous execution of the transactions is called concurrent schedule. Concurrent schedule is nothing but simultaneous execution of the transactions is called concurrent schedule. Okay, fine. Now, just now I've shown you one example of transferring or else depositing 1,000 rupees by my father and my brother into my account simultaneously. In this way, execution leads to incorrect state. That's why we require concurrency control manager to control the execution. It means your concurrent execution may leads to inconsistency, but the serial execution always leads to consistent state. Always leads to consistent state. But concurrent execution May or may not. Don't say it is inconsistent always. It may or may not leads to inconsistent state. Here I will write a note. Concurrent schedules. Previously I wrote a note that serial schedules ensures consistency, but concurrent schedules may or may not ensure consistency, means correct state. Always. May or may not ensure consistency always. Always consistency may be possible, may not be possible. So we can say consistency is not guaranteed by the concurrent schedules, but consistency is guaranteed by the serial schedule. That point you remember. Okay, consistency may not be guaranteed by the concurrent schedules. Because may not possible by the concurrent schedules, still the database system requires to use concurrent schedules. Means database system prefers concurrent schedules only, but not serial schedules. Database system prefers concurrent schedules only, but not serial schedules, Okay. Now you may ask me a question, sir. Serial schedule always ensuring consistent state, means correct state, but concurrent schedules may or may not ensure consistency. But still, why database system is preferring to use concurrent schedules? You may ask me a question, sir, why concurrent schedules are preferable? Why concurrency is preferable? Why concurrency? Here to explain why concurrency, I will take the help of the two transactions as an example of my father's and my brother's transactions. Okay, just assume my father's transaction F is read account A minus 100, write account A. What is my brother's transaction? Read account A equal to A minus A plus 100. Okay, A plus 100. Both are depositing. Okay, 1000. Write A. Okay. Suppose if these two transactions execute serially. Serial execution. Serial execution means first assume either first F then B, or it's first B then F. First F assume read A plus 1000 and write A. Then next B assume read A, same operations now, A plus 1000, write A. If these two operations are executing simultaneously, now you tell me execution of each of the operation will take 1 unit of time. 1 unit means like 1 second or 1 millisecond or 1 microsecond. Sometime it is going to take, right? That may be milli or microsecond. Okay, sometimes maybe take. Suppose if started, each F started then B started, and each operation takes some unit of time. Here I will be using a vertical bar is a timing. At time T1, like 1 unit, this is done. In the next unit, time T2, this is done. In the next unit, time T3, this is done. In the time T4, it is done. At time unit T5, it is done. And last, it is time 6. So means how many units of time it is taking? 6 units of time to finish both F and B transactions. Suppose if these two transactions are to be executed simultaneously. And do remember the transaction may have some IO operations. This read and write are called IO operations, input output operations. What are the input output operations? Read A, write A are called the input output operations. And what are the CPU operations? CPU operation means A equal to A plus 1000 is a CPU operations. Okay. Now IO operation, CPU operations. Fine. Now in a computer system, it is possible to execute both CPU and IO simultaneously. You might have studied in computer organization. In that, both CPU and IO to be executed simultaneously. Means whenever CPU is executing, simultaneously IO operations also be executed, and vice versa. Why? Because as you know the processor is faster, IO is slower. To make a trade-off between fast processor and slow IO devices, it requires to allow both CPU and IO operations to be executed simultaneously. For doing this, we do have various mechanisms in the computer organization. That is like a DMA controller is there, which is going to control the execution of both CPU and IO operations simultaneously. You might have studied about DMA controller and all in CO. Okay, that's why I don't want to elaborate that DMA controller and all. Just what I'm telling you, only one point is you might have studied that in computer system, both CPU and IO operations to be executed simultaneously. Let me give a simple example. You can, while doing the program, you can listen to some music. Or while doing some program, you can take a printout. So listening music is getting from the output device. Getting print is from the output device. Printer is output device. But doing a program is done by the processor. Both you are doing simultaneously. That is called both IO and CPU execution can be done simultaneously at the same point of time. Now, using this point, what we do is whenever F transaction is executing IO operation, the B transaction should perform CPU. Whenever F transaction is performing CPU, B transaction should perform IO operation. Whenever F is performing IO, B should perform CPU operation, and vice versa. Okay, and vice versa. Then in such case, you observe how many units of time it is taking. In the first unit, F is taking reading the value of A. In the second unit of time, F is performing adding 1000 to A, B is performing reading A. And in time T3, F is writing A, B is adding that 1000. At time T4, B is writing A. So both are executed simultaneously. But execution of this two transaction takes 4 units of time only. Means execution time is reduced. And moreover, if F and B is to be executed serially, F has to wait B has to wait for how many units of time? 3 units of time that F is to finish. But here, how many units of time B is waiting only for 1 unit of time. Second unit B is also started. This is concurrent schedule. So means waiting time is also reduced in concurrent schedule. Here I am writing the positives. Shorter waiting times. Why concurrent schedules? First reason, shorter waiting times. Because in the serial execution, B is waiting for 3 units of time. But in concurrent schedule, B is waiting only for 1 unit of time. So the first reason is shorter waiting times. Second thing. So serial execution takes 6 units of time. Concurrent execution takes 4 units of time. Means waiting time is reduced. Sorry, execution time is reduced. So means faster execution is possible. In serial execution, only IO operation or CPU operation is executing at a time. But here IO and CPU is executing simultaneously. Means better utilization of resources is possible. Third one, effective utilization of resources. Effective utilization of CPU and IO resources. Effective utilization of CPU and IO resources. So these are the 3 major reasons to say why concurrent schedules are preferable over the serial schedules. So many students told to me, especially CS students, this question. They were asked this question: what is transaction? What are the asset properties? Explain atomicity, consistency, isolation, durability. Who is responsible for which property? What is mean by a schedule? What is serial schedule? What is concurrent schedule? Serial schedule always ensures consistency. Concurrent schedules may not ensure consistency. Still, database system is preferring concurrent schedules only. Why concurrent schedules are preferred by database system? That question was asked. Many students told me, especially CS, because I never trained to non-CS students. This is the first time. So definitely you can expect even this question also, right? Okay. Now we understood what is a transaction, what are the properties, how transactions are executing, schedules, types of schedules, and serial schedule ensure consistency. Concurrent schedule may not, but database system preferring concurrent schedules only. The reasons also we have seen. Okay, any doubts so far what I discussed? Any doubts? Clear. Naga Karthik Pedisetti. Okay. Vamshi, sir, which schedule perform more efficiently? Concurrent schedules only more efficiently. We will discuss that point also, Vamshi. Okay, right. Chalo, no doubts. Clear. Next, here, what we understood, concurrent schedules are preferring by the database system. Database system is concurrent schedules because efficiency is there with the concurrent schedules. But you may ask me a question, sir, problems are there in the concurrent schedules, but why are you preferring serial schedules only? Sorry, why are you preferring concurrent schedules only? Even concurrent schedule had a problem, database system is preferring, even though concurrent schedule had a problem, database system is preferring concurrent schedules only, not the serial schedules. Why? Why we have discussed. Okay. But even though whatever the problems may be there, the system should be in the correct state. Correct state will be verified based on the concept of serial schedules, because serial schedule always correct state leads to consistent state. So if any concurrent schedule is given, that concurrent schedule, is it leads to correct state or incorrect state? That is to be verified. To verify whether a given concurrent schedule is leading to consistent state or inconsistent state, we will be using a mechanism called serializability mechanism. The serializability mechanism says, any concurrent schedule that when executed, any concurrent schedule that when executed may lead to, or any concurrent schedule that when executed, if equivalent to a serial schedule, if equivalent to a serial schedule, is called serializable schedule. Any concurrent schedule that when executed, if equivalent to a serial schedule, is called a serializable schedule. Serializable. Here you understand serializable mean that not serial schedule, but the effect of concurrent schedule is a serial schedule. Because effect of concurrent schedule is serial schedule, we call it as a serializable schedule. And you know that serial schedule ensures correct state, because execution of concurrent schedule is same as serial schedule, means serial schedule is correct means concurrent schedule also correct. That's why we can call serializable schedule ensure consistency, because these serializable schedules are equal to serial schedules. So here I am writing one note point. One note point I am going to write. Serializable schedules ensure, serializable schedules ensure consistency. Serializable schedules ensure consistency, correctness. Okay, that is what we call serializability. Okay, now How to verify the serializability? 1 minute. Let me connect the laptop charger. I think it is 90% remain. Just 1 minute. Let me connect laptop charger. Yeah. So to ensure whether the concurrent schedule leading to correct state or incorrect state, we will be using a concept of serializability. Okay, we will be using the concept of serializability. Now, what is serializable schedule? The effect of that schedule, concurrent schedule, if equivalent to serial schedule, we call it a serializable schedule. And serializable schedules ensure consistency. Okay. Now, for how to verify? How to verify? You may ask me question, sir. How to verify whether the given concurrent schedule is equal to serial schedule or not? So, to verify serializability, we'll be having a concept of conflict serializability. Conflict serializability. Conflict serializability that we will discuss. Here we will understand the conflict operations. Means we have a mechanism to verify serializability is called conflict serializability. Here we do have conflict operations. Conflict operations. We do have three conflict operations: read operation and write operation by two different transactions. This is one, this is two, assume. Or else we can call I and J. Okay. Read write conflict, we can say. This is read IA, this is write JA. Okay. Read write conflict. And this is write read conflict. Write IA, read JA. And write IA and write JA. Okay. Read, write, write, read, write, write are the conflicts. Okay. Read, write, write, read, write, write are the conflicts. These are called conflict operations. Then you may ask me a question, sir, why these are called conflict operations? Okay, let me explain you. Suppose this is a transaction I, this is another transaction J. Suppose I is performing read operation, J is performing write operation. Okay. In the order from Ti to Tj. Suppose in the order from Ti to Tj means I is reading the value of A and calculating 10% of A, and J is updating the value of A to 2000. Assuming the value of A, is 1000. Okay. First, if I is executed, what value of I is calculating 10% amount. Okay, I is calculating 10% amount. What value of I is going to read? 1000. If it reads 1000, 10% is called 100 rupees. Then J is changing the value to 2000. Now just imagine if these two operations execute in the opposite way. Executes in the opposite way means order is not I to J. Here order is Ti to Tj. Suppose if the order of execution is Tj to Ti. Tj to Ti means first J operation is executed, then I operation is executed, and I is anyhow calculating 10% of A, and J is updating the value of A to 2000. Initially the value of A is 1000. Now first which operation is executed? First J is executing now. If J executed, first J changing the value of A to 2000. Then I started execution. Then read A. Read A, what is going to read? It is 2000s, not thousands. And 10% on 2000s is 200, not 100. Means you are getting some different results right now. It means if you are if the read and write operations of I and J transactions are executing in the order from I to J, you are getting some result. If it is executing in the order from J to I, it is giving some different results. Right now, if it is executing in the order from I to J, one result, J to I, one result. Different results are given. Because different results are given, we can call these are the conflict operations. That's why these operations are called conflict operations. Why? Because the order of operation, if you change it, you are going to get some different results. If you are getting different results, means it is giving conflicting results. That's why we can call conflict operations. Same reason applicable for read write and write read. Here you see read write or write read. So if order you are changing, you are getting some different results. Same logic applicable for write write also. If two transactions are performing write write, say let us say an example, if I and J is there, it is write A, it is write A. Okay, suppose the value of A is 1000 and Ti changing the value of A to 2000s, Tj is changing value of A to 3000s. Suppose if it is executing in this order, Ti first, then Tj next. Or else if it is executing in this order, first Tj, then Ti. Okay, first Tj, then Ti. This is also an possibility. If it is Tj, then Ti. Now look at the value of A is 1000 and I is changing to 2000s, J is changing to 3000s. Here J is 3000s, I is 2000s, correct now? Now look at, if it is executing in the order from I to J, the value of A is going to become first 1000, changes to 2000s, then changes to 3000s. Why? Because J is the last one. So means what is the final state of the system? 3000s. If it is executing, the value of A 1000 is executing J first, then I next. First J changes the value of A to 3000s. And J is changing the value, I is changing the value of A to 2000s. So what is the final state? 2000s. Here what is the final state? 3000s. Right now, what is the final state here? 3000s. Here 2000s. Correct or not? Yes. Means are you getting the same states if these writes are executing in a different orders? No. You are getting different results. That's why we can call conflict operations. Why? Because if the order of execution is disturbed or rearranged, you are going to get conflicting results. That's why these operations are called conflict operations. That's why order of conflict operations in concurrent schedules and in serial schedules definitely should be same. If order of conflict operations in concurrent schedules and serial schedules are both same, then we can say both concurrent and serial schedules is going to give the same output. And moreover, serial schedule ensures consistency. So because even concurrent schedule also giving the same output as serial schedule, then we can call concurrent schedule is also ensuring consistency correct. So means correctness we can verify using the serializability concept based on the conflict operations. That's why we can call conflict serializability. So what are the conflict operations? Read write, write read, write write. Then you may ask me a question, sir, what about read read? Look at, if two transactions are reading the value of A, read A, write A, it is in the order from Ti to Tj, or else it is in the order from Tj to Ti, read A, write A. Either this order or that order. If it is Tj, then Ti. Suppose the value of A is 1000. Now what value of A read by Ti? 1000. What value of J is read by Ti? 1000 only. So means any changes there? No. Here also what value of J reads? 1000. If A is 1000. Then next I reads A, it is also reads 1000. So means any problems are there? No problem. Because even if it is executing in the order from I to J, or J to I, is it causing any problem? No problem. So it means read is not a conflict. What are the conflict operations? Conflict operations are read write, write read, write on the same data, AA, like whatever it may be, same data by different transactions. So means conflict operations are those, instead of are those, conflict operations are operations of different transactions on same data. Operations of different transaction. It is I transaction, it is transaction on same data. Both are on A, and at least one is write operation, and at least one is write operation. See, in all these combinations, you can see minimum one write. This is right here, right here, two writes. Minimum write operation is called conflict operations. Based on the conflict operations, we can identify the serializability of a concurrent schedule. How I can verify? You check it out. Order of conflict operations. In the conflict serializability, what is required is order of conflict operations in concurrent schedule is same as some serial schedule. Is same as some serial schedule. Is called conflict serializable schedule. In concurrent schedule should be. Here I will give you an example. This is schedule 1 having two transactions, T1 and T2. The operations I am writing, read A. Just I will be writing some operations, read A, write A, read A, write A, read B, write B, read B, write B. This is concurrent schedule, undoubtedly, because simultaneous execution is there. And there is one more schedule, S2, T1, T2. Read A, write A, read B, write B, read A, write A, read B, write B. Okay. Now look at. First, you see what are the conflict operations in concurrent schedule, and you see what are the conflict operations in serial schedules. If the conflict operations in concurrent schedule and serial schedules, if both are same, then we can say concurrent schedule is conflict serializable to serial schedule S2. We can say S1 is concurrent, S2 is serial. Why? Because look at when T2 started after T1, means it is a serial schedule. Look at what are the operations are there. How to verify conflict operations? First operation of T1 has to be verified with all operations of T2 in downwards. This read A has to be verified with write A in the downwards. Means read A, write A is a conflict. Read A, read B is not a conflict. Can anyone tell me read A and write B is a conflict? Read A and write B is a conflict? No conflict. Why? Because these are the operations on different data items. Now, conflict is possible with respect to operations on the same data, but not different data. So that read B, write B is not a conflict. Write A, read A is a conflict. Write A, write A is a conflict. With respect to not a conflict. Now look, read A, read B is conflict. It is read A, write not a conflict. Why? Because these are the A data items. This is data, not a B. Write B is a conflict. Write B, read B is a conflict. Write B, write B is a conflict. Okay, these are the three conflicts. Now, similarly, you look what conflicts are there in S2. Read A is conflict with write A, similar conflict. Write A conflict with read A, same conflict. Write A conflict with write A, same conflicts. You can see same conflicts are there. Here, read B conflict with write B. Write B conflict with read B. Write B conflict with write B. So means in S1 and S2, you are getting the same conflicts. Because you are getting the same conflicts in S1 and S2, we can call S1 is concurrent schedule is equivalent to S2, which is a serial schedule. A concurrent schedule, if equivalent to serial schedule, is called a serializable schedule. Is called a serializable schedule. We can call conflict a serializable schedule because it is verified with respect to conflicts, right? So here I can write as some conclusion that the concurrent schedule S1 is so or else we can write in concurrent schedule S1 and serial schedule S2 all the conflicts are same. All the conflicts are same. Therefore S1 is called, okay, therefore S1 is called conflict serializable. Then S1 is called conflict serializable. Okay, in concurrent schedule S1 and S1 and serial schedule S2, all the conflicts are same. Because same conflicts are there means both S1 and S2 are same schedules. And S2 is serial schedule. Serial schedule always leads to consistent. So S1 effect is also same as S2 serial schedule. So S1 is also consistent. We can call. Okay. So what we can call in concurrent schedule S1 and serial schedule S2, all conflicts are same. Therefore, S1 is called conflict serializable schedule, which is equivalent to serial schedule S2 T1 to T2. What is S2? T1 to T2 serial schedule. It means S1 is ensuring consistency because it is equivalent to S2. S2 is also ensuring consistency. This is how consistency is to be verified for the concurrent schedules. Okay, is it clear? And moreover, more bigger problems and all, I feel it is not required. And lastly, if it is clear, the basics are sufficient. That's why I'm not going into much depth. Like this, I'm explaining you. Is it clear? If it is clear, I will explain you just last one small concept about these transactions. One we call concurrency control. Concurrency control. And most database systems uses the concurrency control protocols called lock-based protocols. Okay, the concurrency control protocols are called lock-based protocols. Most database systems uses lock-based concurrency control protocols. Okay, we also called lock-based protocols. What lock-based protocols do is it requires to acquire the logs on a data item before it starts execution. Before a transaction starts execution means before it starts, whatever the data items the transaction requires on the data item, the transaction is going to get a lock. Okay. Now look at, suppose there is a data item A. There is a data item A. Right. Suppose transaction 1 and transaction 2 both wanted to perform some operation on A. And first assume T1 started. Then what T1 do is before it performs an operation on A, T1 put a lock on A. T1 put a lock on A. Whenever T1 puts a lock on A, T2 is going to wait. Now what T2 should do? T2 has to wait. Once T1 completes its operation, T1 going to release the lock. Once T1 releases, T2 is waiting. Now T2 is going to get a lock. It means at any point of time, the transactions are going to be at any point of time, only one transaction can access the data item. So here what log-based protocols requires is, before, here I'm writing some points, before the transaction starts, before the transaction starts, before the transaction starts its execution, the transaction should request the lock. The transaction should request the lock. Before the transaction starts its execution, the transaction should request the lock on a data item. On a data item. And moreover, when more than one transactions are requested, only one transaction can access the data item. Okay, so means among, here I will write a point. Among many transactions, among all the transactions, only one transaction at a time can access the data item, Among all the transactions, only one transaction at a time can access the data item, right? And all the other transactions requesting the same, need to wait until the current transaction releasing the locks. So that such execution is called mutual execution. That's why it means if transaction 1 acquiring means it makes the transaction 1 to complete its execution. Once transaction completes, then transaction 2, if it is waiting for the A, then transaction 2 can take a lock and continue. That's what I told you, an example of my father's and my brother's transactions. Right, this is my account A. Account A is having 1,000 rupees. When my father transaction started first my father transaction going to get a lock on A, read the 1,000 plus 1,000, 2,000 and write 2,000 to the disk. And whenever my father transaction is accessing, what happens with my brother transaction? My brother transaction going to wait. It is going to wait. Once my father transaction is going to release the lock on date because B is waiting now. So no more waiting for B transaction. What B will do, it will take a lock on 1,000 plus 1,000. Any loss occurred, no loss occurs. This is going to happen in the log-based protocols. There are various mechanisms are there, but in-depth knowledge is definitely not required for you. But at least having eyes for you to understand the concept of concurrency control. And if you allow the transaction to take a lock on the data items and other transaction requires to wait. Suppose transaction 1 want to read it and transaction 2 wanted to write it. So when T1 is reading the value by taking a lock, what can T2 allows? Can T2 be allowed to perform a write operation? No. Why? Because T2 is going to wait. It means read-write conflict never be possible. Similarly, write-read conflict never be possible. Similarly, write-write conflicts also never be possible. If no conflicts, schedule always leads to correct state. That is a motto of the topic. Okay, that's about the transaction management and concurrency control. So means here I explained you what is meaning of transaction in a database system, what are the properties of a transaction, and what is the meaning of each property, and who is responsible in a database system to ensure each property, and what are the states of a transaction. Just let me review quickly what we discussed today. Now today I discussed what is a transaction, what are the properties of a transaction, acid properties, what are acid properties, and what is the acronym of ACID and their meaning, and who is responsible for it, what are the states of a transaction. Execution of a transactions is called schedule. Two types of schedule, serial and concurrent. And we discussed a point that serial schedule always ensure consistency. Concurrent schedule may not ensure consistency. And why database system is preferring concurrent schedules? Because of shorter waiting time, faster execution time, and effective utilization of CPU and IO resources. What database system requires consistent state, that is to be verified based on the serializability. What is serializability? The concurrent schedule must be same as some serial schedule. For verifying serializability, we will be using conflict serializability concept. What are the conflict operations? Read, write, write, read, write, write. Why those are called conflict operations explained. And then how to verify that serializability explained with an example. Then finally, concurrency control. Many database systems uses log-based protocols for the concurrency control. What log-based protocols requires is a transaction requires to have some data. First transaction will get a lock on it. Other transactions going to wait. Once a transaction releases the lock, other transaction which are waiting for it, one of them is going to get a lock and continue its execution, so that it is avoiding the conflicts like read, write, write, read, write, write conflicts. It is going to avoid it. Because it is avoiding the conflicts, the system state is correct. That's why many database systems uses concurrency control protocols, log-based concurrency control protocols for their concurrency control. Okay. That's about transaction management and concurrency control. Hope definitely this knowledge what I gave you, it will be helpful for your interviews. And tomorrow I'm going to, tomorrow we don't have a class. Actually, day after tomorrow we have a class on Friday. On Friday we are going to discuss about recovery management system. Means if a failures occurs in a database system due to some disk crash occurs, or transaction failures, or head crash occurs, or any other kind of failures, a failure may lead to loss of information. If information loss occurs, system has to recover from the loss. To recover from the loss, it has to maintain some data about the transaction, so that recovery is possible. How database system is going to maintain some data for recovery process, how recovery is going to be done, that we are going to discuss in the day after tomorrow class. And also I'm going to explain in brief about indexing concepts, so that your DBMS domain training is going to be finished. Okay, thank you. Hope you are enjoying. Good day. See you on day after tomorrow. If anybody is having any doubts, you can ask me. I will wait for at least 1 or 2 minutes. If you ask me, I will wait for more than that also. If no doubts, happily you can leave the session. Thank you.